This is 9.4, all about solving rational equations. All right, guidelines for solving rational equations, follow your instincts. If it's a proportion, you can cross multiply. Otherwise, you may want to multiply everything by the LCD of all terms. This is just kind of a general rule of solving equations. Dividing by x will usually not get you anywhere because you'll just end up with a compound fraction. Also, a key piece in this section, you need to check for extraneous solutions. There is room for extraneous solutions to come about, so you must check all the answers that you get for these. All right, so consider, how could we solve this? Notice that the x is in the denominator. What we're going to do is multiply everything by the LCM of the denominators, right, the LCD. So looking at 6, 18, and x plus 3, the LCM of the denominators is actually 18 times the quantity x plus 3. The reason why that 6 is not in there is because 6 goes into 18. So what we're going to do is we're just going to multiply everything by 18 times x plus 3, okay? We're not multiplying by 18 times x plus 3 over itself. We're not doing that. We're multiplying by this over 1, actually, okay? All right, let's see what happens with 4 over x plus 3. We end up with 4 times 18 x plus 3 all over x plus 3. And then we end up with 5 times 18 times the quantity x plus 3. Sorry, my pen is lagging a little bit. Divided by 6 equals 23 times 18 times the quantity x plus 3 over 18. You may be wondering, hey, why didn't you multiply 23 and 18 together? Why didn't you multiply 5 and 18 together, 4 and 18 together? The reason why is because of what we're about to do, right? Now we can see, oh, those x plus 3's, they cancel. Hey, this 18 and the 6, this is going to end up becoming a 3 up top. And those 18's cancel out, right? If we had multiplied everything together, it would be like almost more work for us. Okay? So really, we just have 4 times 18, which is 72, plus 5 times a quantity, or excuse me, 15. 5 times 3 is 15, times x plus 3 equals 23 times the quantity x plus 3. And now we don't have any fractions anymore. Great. We can just distribute and solve. Okay, distribute and solve. So 72 plus 15x plus 45 equals 23x plus 69. We want to get our numbers on one side and our x's on the other side. So say that I want to take 72 plus 45, then subtract 69 from that. I would get 48 over here on the left. And then say I take 23x minus 15x, and I move my x's over to the right side, then I would have 8x over here. Meaning that x equals 6. But remember, we have to check. We have to plug 6 in to our original equation, right? So check, does 4 over 6 plus 3 plus 5/6, does that equal 23 over 18? That's our question. All right, and choose your calculator for this. Once you do that, you will notice that this is 4/9 plus 5/6. If we get a common denominator with that, we actually do find out that the left side is equal to 23 over 18. So 6 is our solution. All right, taking a look at this one. Notice we have fractions. We want to multiply by the least common multiple of the denominators, okay? So what is the least common multiple of our denominators? You're going to notice that it's 24v. So we want to multiply everything by 24v over 1. All right, so this becomes 24v times the quantity v plus 2 over 8v minus 5 times 24v over 12 equals 24v over v What's wonderful about this is that it causes everything to cancel out, so we will have no more fractions. 24v over 8v, that's going to cancel out, give us 3 up top, so we have 3 times the quantity x plus 2 that we're left with. The 24 and the 12 can cancel to give us a 2, so we have 5 times 2v. I'm sorry, I changed this to an x. Silly me. And then 24v divided by v just gives us 24. Now let's distribute here. Clean up a little bit. 3v plus 6 minus 10v equals 24. Let's get our variables on one side and our numbers on the other side. Okay, negative 7v equals 18, meaning v equals negative 18 sevenths. Now we have to check it. All right, and checking these is not the most fun thing in the world, but using a calculator can make it a little bit more straightforward for us. All right, so when you're plugging this into check, you want to verify that the original is true when you plug in negative 18 over 7. So what I'm going to do is plug in the left side of the equation in one line of Desmos. And then I'm going to hit enter and I'll plug in the right side on the other line and verify that those two quantities equal each other. Okay, so looking at this left side, we have a fraction, right? And our variable v is being is having 2 added to it. So we're going to plug in negative 18 sevenths for v plus 2. Then for our denominator, it's 8 times our variable, negative 18 sevenths. I'm just plugging it in just like that. Okay, minus 5 twelfths. So that is equal to negative 7 eighteenths. So I'm going to hit enter now, and then I'm going to verify the right side, 1 divided by negative 18 sevenths, that value for v, and look at that. They're equal. So because those two quantities are equal, we checked it. It's good. You can just put a check mark, but please, 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 in your work, I need some indication that you have checked your solutions. Okay, I need a check mark. I need the word check. Otherwise, I'm going to assume that you did not check if it was extraneous. Okay, looking at this one. If we factor, I'm going to recommend that we rewrite this with that middle piece fully factored. Okay, x squared minus x minus 10, that can be factored. Let's see, it can factor, well, actually, we can factor the denominator, not the numerator. Okay, minus x minus 10. Our denominator is x plus 5, x plus 3 equals 3 over x plus 3. So we factored that denominator, and then that allows us to see that the least common multiple of the denominator, or the LCD, is x plus 5 times x plus 3. So that's what we're going to multiply everything by. Okay, we're going to multiply everything by this over 1. So when that happens, we end up with 2x times x plus 5, x plus 3, all divided by x plus 5, minus, I'll put this in parentheses, x squared minus x minus 10 times x plus 5, x plus 3 over x plus 5, x plus 3, right? That's our original denominator, equals 3 times x plus 5, x plus 3, over x plus 3. Now cancel whatever cancels. Those x plus 5s will cancel. Here both quantities will cancel. And then here the x plus 3s will cancel. And then we end up with 2x times x plus 3 minus, make sure you put this in parentheses, really careful, it's really easy to mess up this sign here, okay, minus x minus 10, this entire quantity is being subtracted. And that's equal to 3 times the quantity x plus 5. And now we have no more fractions, we can distribute and solve. So we're going to distribute a whole bunch. We love distributing. 2x squared plus 6x minus x squared plus x plus 10 equals 3x plus 15. All right, and so we're going to end up with a quadratic. So we need to get to a point where we're equal to 0, okay? 2x squared minus x squared gives us x squared. 6x plus 6x, excuse me, 6x plus x gives us 7x, minus this 3x gives us a 4x. Then here 10 minus 15 gives us negative 5. So we have x squared plus 4x minus 5. And now we have a quadratic, so our options to solve, because we're equal to 0, our options to solve are to factor. We could also use the quadratic formula. We could also complete the square. Remember last video I said that when we get to this point in algebra, typically most of what we give you will be factorable, okay? And that's true here. X plus 5, x minus 1 equals 0. Meaning x equals negative 5, x equals 1. We have to check both of these. We have to see if they're extraneous. Okay, so check negative 5, check 1, plug them both into your calculator. So you can use the method that I showed here where you use the left side, hit enter, use the right side, hit enter, convert them to fractions, and verify that those two values are equal. When you do that, you will find out that one of them works and one of them doesn't. Okay, negative 5 does not work, so this is not a solution. 1 does work, so your only solution here is x equals 1. X equals negative 5 is extraneous. All right, and think about that for a second. If we look at the original function, if we try to plug in negative 5 for x, right here, that would cause a 0 in the denominator, so that would be undefined. So that's another way for you to check and see if something's extraneous. Just look and see, do any of your values for x cause you to have an undefined denominator? Okay. There are 2 more in your notes. Give them a try. For this one, the least common multiple that you're going to multiply everything by is 2 times the quantity, x minus 6. I'm going to go a little bit more quickly through the process here. So I already see that these x minus 6 quantities are going to cancel, so I'm not going to write them. Okay, and then here I'll end up with 7 because I can see that 2x minus 12 would end up canceling out. And then here I will write both quantities because this one is not a fraction. Right? Let's get to a point where we have 2x, which is equal to 19 plus 6, 25. X equals 25 over 2. Now check it. Check it in your calculator. Use this method. When you check it, you will verify that it is a solution. Okay, last one. This is very similar to example 2. This denominator here will factor, and when it factors, you'll notice that it's the 2 quantities over here. So your least common multiple that you're going to multiply by is this. Okay, multiply everything by that. You end up with x times x plus 7 plus 5 times x plus 3 equals x minus 13. Distribute. Right? When you distribute, you end up at a point where x squared, distribute combined like terms, you end up with x squared plus 11x plus 28 equals 0. Again, we have a quadratic. So your choices are to factor, quadratic formula, or complete the square. This one will factor into x plus 7, x plus 4, x equals negative 7, x equals negative 4. Your solutions, we need to check them though. Check negative 7, check negative 4. You can use this method. You can also take a look at your original and see, are you going to have any undefined denominators? Look right here. If we plug in negative 7, then we would have an undefined denominator. So negative 7 cannot work. Just negative 4 will. All right, that's all I got. Take a look at your practice and let me know what questions you have.